theory for gamma ray bursts endorses a relativistic fireball. So we'll talk about the fireball, but basically a gamma ray burst is a relativistic environment. Things happen very fast, things happen with a lot of energy, so it's not, you can't do non-relativistic in that particular environment. The observation of gamma ray bursts, of gamma ray photons, guided this theory. In fact, the observed photon spectrum was the starting point for gamma ray burst theorists. So it's not that the gamma ray burst theorists just woke up one day and thought that they will come up with a theory for gamma ray bursts. First, gamma ray bursts were discovered. Then people were like, oh my gosh, what are these things? Then we actually observed photons in the form of gamma rays from gamma ray bursts, or more of them. We also observed the photon spectrum. And then theorists got to work about, okay, how do we kind of explain this? So up until 1994, gamma ray bursts had been observed to emit photons in the energy range between a few keV and a few tenths of MeV. In 1994, however, a very energetic burst was reported by some paper that I cite here that emitted photons of energy up to 18 GeV. That's a lot for a photon. Other observations, such as by the Fermi Observatory, have confirmed this hardness of the photon spectrum from gamma ray bursts. It was argued that since observed photons from the gamma ray emitting region of the gamma ray burst do make it out to us, the optical depth in this region of tau gamma gamma must be less than 1. So now the optical depth, tau gamma gamma, is a function of the Lorentz factor, which we can, there's a review on this by Waxman, the author. And thus, from tau gamma gamma, it was obtained that the gamma ray emitting region in a gamma ray burst must be moving with the Lorentz factor of greater than equal to 100. So some relativity math later, we have a Lorentz factor. Thus, the fireball model says that the gamma ray emitting region of a gamma ray burst is relativistically expanding. It was theorized that gamma ray bursts are produced by the dissipation of the kinetic energy of a relativistically expanding fireball. So it's an expanding fireball and it's relativistically expanding. And that's because we got some other math in place. Waxman, there's a bunch of papers by Waxman, Waxman. I cite them in my thesis. They have done the math. The Lorentz factor is greater than equal to 100. So it was theorized that gamma ray bursts are produced by the dissipation of the kinetic energy of a relativistically expanding fireball. The expanding fireball has regions of overdensity moving at different speeds. So basically, it's kind of like there's more matter and less matter. The expanding fireball has regions of overdensity moving at different speeds. When these regions collide, shocks are produced. So we will now get into these shocks. The particles are accelerated to relativistic speeds. The relativistic ejecta of a gamma ray burst may undergo internal collisions resulting in prompt emission, as well as collisions with the interstellar medium resulting in afterglow emission. So this is the interesting part. So depending on which region and the collision happening where. So again, I'll read that part. The expanding fireball has regions of overdensity moving at different speeds. So we get that. It's a relativistically expanding fireball, and there are regions of overdensity moving at different speeds. So of course there will be some collisions, right? Now, because all of this is happening relativistically, not only are there collisions, there are going to be some shocks that are produced because of that. And particles get accelerated to relativistic speeds. So it's almost like we don't need a human-made particle accelerator. This environment is a natural particle accelerator where there's these like relativistic expansion and shocks happening due to collisions and things like that. So now remember about the collisions happening in the different regions. Depending on if there's internal collisions, those actually will later on you'll see lead to the prompt emission. And if there's collisions with the interstellar medium, because this stuff is happening here, there's also the environment around it, interstellar medium, and collisions with that can result in the afterglow emission that we will talk about. So again, the relativistic ejecta of a gamma ray burst may undergo internal collisions resulting in prompt emission, as well as collisions